Circle the time that is 30 minutes before midnight. So some of these times are AM times and others are PM. And if it's 30 minutes before midnight, that will be a time in the evening. So we need a PM time. Now 30 minutes before midnight is 30 minutes before 12 o'clock. So if we subtract 30 minutes from 12 o'clock, that's 11:30, because there are 60 minutes in an hour and 60 minus 30 is 30. So we need 11:30 p.m. Here are 4-digit cards. We have 4, 6, 2 and 7. Use all 4-digit cards to make this sum correct. So we need to find numbers that give a total of 100. We can start by thinking what our ones digits could be. And our ones digits will need to give a total of 10. The total of our ones digits needs to be 10 because that will give us 0 as the ones digit of our answer. So we can have 6 and 4 as our ones digits because 6 plus 4 is 10. So that will give a number that ends in a 0. And now we need to think what our tens digits could be. We've already made one 10 by adding our ones, so we need 9 more tens because there are 10 tens in 100, and if we've already made one 10, we need 9 more tens to make 100. So we can have 7 and 2 because 7 plus 2 is 9, but then we get our 10th 10, so we get to 100 by adding our ones digits. And we can check, perhaps by doing a column addition, that 76 plus 24 is 100. But there are different possible answers, because if we switch digits in the same place value, we'll get the same answer. So we could swap our ones digits and have 74 and 26, and that will give a total of 100 as well. Or we could have 24 and 76 if we swap our tens digits. Stefan makes this design on a square tile. He turns the tile, put a tick on the tile below that has the same design as Stefan's tile. So if we rotate his tile a quarter turn anti-clockwise, we can see that it now looks exactly the same as this tile here. So that's our answer. In this diagram, the rule is double the number in the square and add the number in the triangle to make the number in the circle. Use the same rule to write the missing numbers below. So double means multiply by 2. So in the example they've given us, if we double 15 or multiply 15 by 2, we get 30. And then when we add 40, 30 plus 40 makes 70. So let's look at this diagram here. We have 35 in the square, so to double that, we can multiply it by 2 to get 70, and then we need to add the number in the triangle, and 70 plus 15 is 85. So that's the number in the circle. Now for this diagram, we don't know the number in the square, but we do know that when we double it and then add 10, so add the number in the triangle, we get 150. So before we added the 10 in the triangle, we would have got 140. So if we double this number here or multiply it by 2, we get 140. So we need to think what times 2 is 140. Well, if we divide 140 by 2, we get 70. So that tells us that when we double 70 or multiply 70 by 2, we get 140. And then when we add 10, so add the number in the triangle to that, we get a total of 150. So that's the number in the circle. This table shows where 100 people went on holiday in 2007 and 2008. how many more people went to Wales than to Scotland in 2008? So we can see that 2008 is this column here. So we can see that 28 people went to Wales in 2008 and 13 people went to Scotland. Now the question asks how many more, so we need to find the difference. And to find the difference, we subtract. 28 minus 13 is 15, so that means 15 more people went to Wales than to Scotland. Now, which country had the greatest increase in visitors from 2007 to 2008? So increase means getting bigger or more. So we can see that for Spain, in 2007 there were 18 people, but 2008 had 26 people. So that's an increase because 26 is larger than 18, and 18 plus 8 is 26, so the increase for Spain is 8 people. But for England, the number in 2008 is smaller than the number in 2007, so that's not an increase at all. That's a decrease in the number of people going to England in 2008. And for Scotland as well, we have a decrease, not an increase, because the number is getting smaller, not larger. For Wales, we have 19 and 28, so that's an increase of 9, because 19 plus 9 is 28. And for the USA, we have an increase of 12, because 4 plus 12 is 16. So that means the USA had the greatest increase in visitors from 2007 to 2008, because the number increased by 12. One battery weighs the same as 60 paper clips. One pencil sharpener weighs the same as 20 paper clips. How many pencil sharpeners weigh the same as one battery? So we know that a battery is the same as 60 paper clips and a pencil sharpener the same as 20. So if a pencil sharpener is 20 paper clips, another sharpener will be another 20, so 20 plus 20 is 40, and then another sharpener, so a third sharpener, will be 60 paper clips, so we'll have the same weight as one battery. So our answer is 3 sharpeners, because 3 times 20 is 60. Now, how many paper clips weigh the same as 2 batteries and 4 pencil sharpeners together? So 2 batteries, we can work out 2 times 60, because each battery is the same as 60 paper clips. So 2 times 6 is 12, and then we need a 0 on the end, so that's 120. But we also have 4 pencil sharpeners, and they each weigh 20 paper clips. So we can work out that 4 times 20 is 80, because 4 times 2 is 8, and we need an end 0. So we know that the batteries weigh 120 and the pencil sharpeners weigh 80. So together we can work out 120 plus 80, and that gives us 200. So our answer is 200 paper clips. Calculate 48 divided by 3. We can set this out as a short division. 4 divided by 3 is 1 remainder 1, because 1 times 3 is 3, and then we need 1 more to make 4. And now 18 divided by 3 is 6, so our answer is 16. Draw the reflection of the shaded shape in the mirror line. So we need to reflect the shape so that we have the same on both sides. And the way to do that is to dot the corners. So these 2 points are on the mirror line, so they will be on the mirror line when we reflect the shape. To get to this point here, from the mirror line, we go down half a square and then another one, so we can go up half a square and then another one and dot our point. This point here is down a half and then one, so we can go up a half and then one. For this point here, we go down half, so we can go up half. Then for this point here, that's down a half and then another one, so we can go up a half and then another one. And then this point here again is down a half and then one, so we go up a half and then one. Now all we need to do is connect our corners. So because this dot is connected to this dot here, we can draw a line here. Then we have a line across, so we can draw a line across, and then we can complete our shape by joining up our points, and we've reflected the shape in the mirror line because we have the same reflected on both sides. A fraction of each shape is shaded. Match each fraction to the correct place on the number line. One has been done for you. So if we look at our number line, we have 0 and 1 marked on the line, and to get from 0 to 1, we have 1, 2, 3, 4, 5, 6, 7, 8 lines. So our number line is going up in eighths. Now here we have 1/4, and that's matched to 2/8 because 1/4 is equivalent, so the same value, as 2/8. Now we have 1/2, and we can spot that that's equivalent to 4/8, so we can draw a line here. 1/2 is the same as 4/8 because we can multiply both the numerator and denominator by 4. And now here we have 3 parts out of 4 shaded, so that's 3/4. 4 times 2 is 8, and 3 times 2 is 6. So 3/4 is equivalent to 6/8, so we need to draw a line matching here. This graph shows the age of players at a football club. How many players are aged 30 or younger? So from the bar chart, we can see that we have the age in years along the bottom. So this bar, 16 to 20, will be players younger than 30, but so will this bar for players of 21 to 25, and this bar, which is for players from 26 to 30. So we need to find the total of these 3 bars, because these are all bars for players who are 30 or younger. So for this bar, we have between 6 and 8, so that's 7. For this bar here, we have 8, and for this bar, we have 12. So 12 plus 8 plus 7 is 27, so 27 players are aged 30 or younger. Now, a player aged 36 and a player aged 39 join the club. Add this information to the graph. So the players are 36 and 39, so they both need to be added to this bar here, because this bar is for players from 36 to 40. So the bar at the moment shows 4, but if we add another 2 players, then the bar will need to show 6, because 4 plus 2 is 6. So we need to change the bar so that it's this height. Amir and Lara buy some fruit. Grapes cost £2.50 for 1 kilogram, peaches £1.99 for a box, and pineapples £1.40 each. Amir buys 2 pineapples and a box of peaches. How much does he pay? Well, first let's find out how much 2 pineapples cost. Pineapples are £1.40 each, and 2 times £1.40 is £2.80. He also buys a box of peaches, and a box of peaches cost £1.99. So we need to work out £2.80, so what he spent on pineapples plus £1.99. When we're adding a value with 99 pence, what's easier is to use adjusting. So £1.99 is just 1p less than £2. So if we had £2.80 plus £2, that would be £4.80, and 1 pence less than that is £4.79. So here, rather than using column addition, we can use adjusting. £2.80 plus £2 is £4.80, but because £1.99 is 1 pence less than £2, £4.79 is our answer because that's 1 pence less than £4.80. So he pays £4.79 altogether for 2 pineapples and a box of peaches. Now Lara buys half a kilogram of grapes and 1 pineapple. How much change does she get from £5? So we know that 1 kilogram of grapes would cost £2.50, but because she's only bought half a kilogram, we need to find half of £2.50, and to find half, we divide by 2. Now £2.50 divided by 2 is £1.25, and you might need to use short division here. Then she also buys 1 pineapple, so as well as £1.25 on grapes, she spent £1.40 on a pineapple as well, and that comes to £2.65. But the question doesn't ask how much does she spend, it asks how much change does she get. So we need to subtract what she spends from £5. So work out £5 minus £2.65. We could use column subtraction for this, or we could count on. So from £2.65, another 35p makes £3 because 65 plus 35 is 100, and then from £3 to get to £5 we need £2 more. So altogether that's a difference of £2 and 35 pence, so the change is £2.35. Or if counting on is a bit too confusing, you can just set the question out as a column subtraction and answer it in that way instead. So she gets £2.35 change. Amir says all numbers that end in a 4 are multiples of 4. Is he correct? Explain how you know. So we need to remember that a multiple of 4 is a number in the 4 times table, or a number that can be divided by 4 without giving a remainder. So Amir is wrong, and when the person is wrong, to explain how we know, we can just give an example. 14 ends in a 4, but it is not a multiple of 4 because it's not in the 4 times table. Here are 6 quadrilaterals with their mathematical names. Lara chooses one of the quadrilaterals. She says it has 2 acute angles. All 4 sides are the same length. Which quadrilateral did Lara choose? So remember, a quadrilateral is a 4-sided shape because quad means 4. Now if we look at the square, we can see that all 4 sides are the same length. But Lara can't have chosen the square because she chose a shape which has 2 acute angles, and the angles in a square are right angles. Remember, an acute angle is less than a right angle. So if we look at the parallelogram, we can see that we have 2 acute angles, one here in the bottom left and one here in the top right, and then we have 2 obtuse angles as well. But Lara can't have chosen the parallelogram because we know that she chose a shape where all 4 sides are the same length, and we can see 2 shorter sides and 2 longer sides. So let's look at the rhombus. With a rhombus, all 4 sides are the same length, and we have 2 acute angles. We have 2 angles that are less than a right angle. So because we have 4 sides of the same length and 2 angles which are acute, we know that Lara must have chosen the rhombus. Stefan chooses one of the quadrilaterals. He says it has more than one obtuse angle, it has no parallel sides. Which quadrilateral did Stefan choose? Well, if we look at the kite, we can see that it has 3 obtuse angles, so that's more than one obtuse angle, and it has no parallel sides, so Stefan must have chosen the kite. Remember, parallel sides are sides or lines that would go on forever without crossing if they were extended. So if we look at the trapezium, though it has more than one obtuse angle, it has a pair of parallel sides, because these lines, if we extended them, would go on forever and never cross. So Stefan must have chosen the kite. Circle 2 decimals that have a difference of 0.5. Remember, the difference is what we get when we subtract. So we have 0.2, and if we needed a difference of 0.5, we would need to subtract that from 0.7. But 0.7 isn't one of our options, so let's move on to the next number. We have 0.25. To make a difference of 0.5, we would need to subtract that from 0.75. That would give us 0.50, but remember, 0.50 is the same as 0.5 because we can ignore zeros on the end of decimals. And we do have 0.75 as one of our options, so we need to circle 0.25 and 0.75. Each of these cards has 2 numbers on it. Stefan chooses one card without looking. He adds the 2 numbers together. What is the most likely total of the numbers on his card? So let's find the total for each card, because he adds the 2 numbers together. So 6 plus 4 is 10, 1 plus 7 is 8, 5 plus 7 is 12, 3 plus 5 is 8, 6 plus 2 is 8, and 6 plus 6 is 12. So we need the most likely total. So we can see that we have one card which would give a total of 10, we have 3 cards that give a total of 8, and 2 cards with a total of 12. So the most likely total is 8, because that's the total for 3 cards, and 12 is only the total for 2 cards. This container has 900 millilitres of water in it. Lara pours out some water so that it looks like this. How much water has Lara poured out? Well, first of all, we need to find out what each of these little lines represent. So, to get from 0 to 300, we have 1, 2, 3, 4, 5, 6 lines. So if we work out 300 divided by 6, that will tell us what each line represents. 300 divided by 6 is 50, so each of these lines stands for 50. That means the water now is at 550. But the question wasn't asking us how much water is in this beaker now. The question was asking us how much has Lara poured out. So she started with 900 and now she has 550. So if we find the difference by subtracting, and we might need to use column method for this, but we get 350. So Lara has poured out 350 millilitres. Then she pours out another 150 millilitres of water. Draw an arrow to show the new level of the water. Well, we know that each of these lines stands for 50. So if she's poured out 150, that's 3 lots of 50. So our arrow is going to be 3 lines down from where it is here. Or we could work out that we have 550, so if we take 150 away, we will get 400. So because each of these lines stands for 50, we have 300, then 350 is the next line, and 400 will be the line above that. So we need to draw our arrow here. Amir has 3 parcels. Parcels A and B together weigh the same as parcel C. So on the balancing scales, we can see A and B has the same weight as C. Now the 3 parcels weigh 800 grams altogether. Parcel A weighs 250 grams. How much does parcel B weigh? So because they weigh 800 together, if we divide by 2, that gives us 400. So we know that the total of A and B will be 400 and C will be 400 because the scales balance and the total weight is 800. So that means we need half the weight. We need 400 on both sides. But we want to know how much does parcel B weigh. We know that A weighs 250. So we have 250 plus B equals 400. So what we can do is subtract 250 from 400, and that gives us 150 grams. So A, we're told, is 250, B, we've worked out, is 150, and C, we worked out, is 400. And if we add those 3 weights together, we can check that we get 800 grams. Write all the numbers between 50 and 100 that are factors of 180. So remember, a factor is like the opposite of a multiple. This question is asking us which numbers have 180 in their times tables, but they only want numbers between 50 and 100. So we can find factors by dividing. 180 divided by 1 is 180, so 1 and 180 are factors. If we divide by 2, we get 90, so 2 and 90 make another factor pair for 180, because notice 2 times 90 is 180. If we divide by 3, that gives us 60. If we divide by 4, we might need to use short division for this, but that gives us 4 and 45. If we divide by 5, we get 36, so 5 and 36 are factors as well. Now we could keep going. If we divide by 6, we'll get a whole number as well, and 9, 10, lots of other numbers are also factors of 180. But we don't need to waste time finding all of the factors if we can spot a pattern here. Notice the divisor is increasing and the quotient is decreasing each time. Now we've already gone below 50, so we don't need to do anything else. We just need to find which factors we have here are between 50 and 100. So that's 90 and 60. So 60 and 90 are numbers between 50 and 100, and they're factors of 180 because 180 is in the 60 times table, that's 3 times 60, and in the 90 times table, that's 2 times 90. Calculate 602 times 57. So 2 times 7 is 14, so 1, 4. 0 times 7 is 0, plus 1 is 1, and 6 times 7 is 42. Now we can multiply by the 5 that's in our tens, but first we can cross out our working and write a 0 as the ones digit of our second answer line. So 2 times 5 is 10, that's 1, 0. 0 times 5 is 0, plus 1 is 1, and 6 times 5 is 30. So now if we add up our answer lines, 4 plus 0 is 4, 1 plus 0 is 1, 2 plus 1 is 3, 4 plus 0 is 4, and nothing plus 3 is 3. so that's 34,314. Lara has some identical rectangles. They are 7 centimetres long and 2 centimetres wide. She uses 5 of her rectangles to make the large rectangle below. What is the perimeter of the large rectangle? So we can write what we know onto our diagram. We know that the shorter sides are 2 centimetres and the longer sides are 7. And we also can remember that the perimeter is the distance around the outside of the shape. So we have 10 lengths of 2 centimetres, so that's 20 altogether. And then we have 2 lengths of 7 centimetres, so that's 14 altogether. So if we add those, we can see that the total length around the outside of the shape, so the perimeter, is 34 centimetres. Now, what is the area of the large rectangle? So there are different ways that we can do this. We could find the area of one small rectangle and then multiply that by 5, because with area you can multiply. The area of a shape is just how much space it takes up, or how much stuff there is on the inside of a shape. And to find the area of a rectangle, we multiply the width and length. So 2 times 7, or 7 times 2, is 14. So the area of a small rectangle is 14 centimetres squared. So because this large rectangle is made up of 5 of these, we can multiply 5 by 14 centimetres squared, and 5 times 14 is 70. So the area is 70 centimetres squared. Or we could write what we know onto our diagram. So we know that the longer length is 7, and then each rectangle is 2 centimetres wide, so we have 2, 2, 2, 2, 2, and 5 times 2 is 10. So then, because this larger rectangle has a width of 7 and a length of 10, we can multiply 7 by 10, and again we get the same answer. We get an area of 70 centimetres squared. 40 children predicted who would win the boys' race at Sports Day. This pie chart shows their predictions. So the pie chart here shows the predictions for 40 children. 10 children predicted the winner of the race correctly. Who won the race? Explain how you know. So there are 40 children making predictions, so the pie chart is 40 children, but only 10 children got it right. So which of these shows 10 if the whole pie chart is 40? Well, Jack won the race because the pie chart shows 1/4 for Jack, and 1/4 of 40 is 10. And we know that 10 got it right, so 10 children out of 40 must have chosen Jack. And 10 out of 40 is the same as 1/4. And Jack has 1/4 of the pie chart, which we know because we can see a right angle here. And when we have a right angle in a pie chart, that indicates 1/4. Now, what percentage of the children predicted that Stefan would win? So we can see the section of the pie chart for Stefan is here. But to work that out, we need to find the percentages for Amir and for Jack as well. So Amir's percentage will be 50%, because we can see that this covers half of the pie chart, and 1/2 is 50%, because 1/2 is equivalent to 50 hundredths, and a percentage is a fraction with a denominator of 100. Now Jack will be 25%, because that's 1/4, and 1/4 is equivalent to 25 hundredths, so 25%. Now percentages need to add up to 100% if we're finding a total. So we have 50, 25 and 5, so that's 80 altogether. So 80% of the pie chart is not Stefan, So if we subtract 80 from 100, that tells us that 20% of the pie chart is for Stefan, because 50 plus 25 plus 5 plus 20 totals 100%. So 20% predicted that Stefan would win. Two of the fractions below are equivalent. Circle them. So we have 2/3, 6/10, 9/12, 10/15, and 16/20. To see if fractions are equivalent, we can use multiplication. But 10 isn't in the 3 times table, so we can't find a fraction equivalent to 2/3 with a denominator of 10. But 12 is in the 3 times table, so we can see if 2/3 is equivalent to 9/12. 3 times 4 is 12, and when we're finding equivalent fractions, we do the same to the numerator, and 2 times 4 is 8. So 2/3 is equivalent to 8/12, not to 9/12. So let's see if 2/3 is equivalent to 10/15. 15 is in the 3 times table, 3 times 5 is 15, and 2 times 5 is 10. So we've shown here that 2/3 and 10/15 have the same value. They're equivalent, so they're the fractions we need to circle. ABCD is a rectangle drawn on a coordinate axis. The sides of the rectangle are parallel to the axes. What are the coordinates of D and E? So remember, with coordinates, we write the x coordinate first and then the y coordinate. And we can see that point D is in line with point A, which has an x coordinate of -10. So that means the x coordinate for point D is -10 as well. Then for the y coordinate, we can see that point D is in line with point C, and that has a y coordinate, a second number, of -4. So the y coordinate of D will be -4 as well. So now let's look at point E. That's on the y-axis, so it will have an x coordinate of 0. And then to find the y coordinate, we can see that point E is in line with point A, and because that has a y coordinate of 8, the y coordinate for point E will be 8 as well. This design has one large square and 2 identical small squares. The design measures 36 centimeters by 28 centimeters. Calculate the length of a side of the large square. So if we look at this length of 28, that's the total of the length of one large square and one small square. So we can write one large plus one small equals 28. And if we look at this length of 36, that's one large square, but this time we have the length of 2 small squares. So we can write one large plus 2 small equals 36. So we can see that what's different about these is that our second statement, so this statement down here, this length here, has one extra small square. So we can take the length of one large square and one small square, and if we rotate it and move it down, we can see that it's the same size as one large square and one small square here, because remember, squares will have sides that are all the same length. So we have 28 plus an extra small square is 36. Now 28 plus 8 is 36, so the length of one small square must be 8 centimeters. This second statement we've written is 8 larger, and all that's different about it is that it has one extra small square. So if we know that this length is 8, the other length of the small square will be 8 as well, because the small squares are identical. So we have 8 plus a large square is 36. Now 8 plus 8 is 16, And then 16 plus 20 is 36. So that means the length of one large square is 20 centimetres. And we can see that if we have 8 here and 20 here, that adds up to 28. So we can be confident that we've got this correct. The length of a side of the large square is 20 centimetres.